I'm Tim. This PCBSYNC.
In this video, we will introduce a Rogers material specifically designed for millimeter wave radar, the RO4830. RO4830 belongs to the Rogers RO4000 thermoset material platform and uses a glass fiber reinforced ceramic filled hydrocarbon resin system. It is mainly targeted at 76 to 81 GHz automotive radar sensors, providing a cost-effective alternative to traditional PTFE materials for millimeter wave projects. Let's first look at the most important electrical parameters of RO4830. Under 77 GHz conditions, the design decay dielectric constant of RO4830 is 3.24. It is available in two dielectric thicknesses, 5/1000 inches and 94 10/1000 inches, which are approximately 127,000 millimeters and 239,000 millimeters. At 10 GHz, the typical DF dissipation factor values for the two thicknesses are 0.0033 and 0.0032 respectively. At millimeter wave frequencies, you can't just compare DF, copper foil roughness, line width, dielectric thickness, connector transitions, and manufacturing tolerances will also significantly affect insertion loss. Shown on the screen is an example of a 4-layer open source FMCW RF radar front end and antenna switching PCB. This project does not operate at 77 GHz, nor is there any information proving that it uses RO4830. We are simply using it to illustrate the basic structure of a multi-layer radar board. The typical use of RO4830 is not to replace the entire PCB with high-frequency material, but rather to serve as a high-frequency outer layer in a hybrid multi-layer board with FR4. Millimeter wave antennas, short RF feed lines, and critical transitions can be placed on the RO4830 outer layer, while FR4 is used underneath for power control and general digital interconnections. This approach balances high-frequency performance with overall board cost. We can see that the central area of this PCB is connected to different receiver or antenna interfaces through multiple short wires, and there are also a large number of via grounds arranged around it. Although this is a lower frequency FMCW radar project, when it comes to 76 to 81 GHz, these layout principles become even more stringent. First, keep RF traces as short as possible and minimize unnecessary bends and pats. Second, the traces should have a continuous reference ground underneath, and grounding vias should help confine the return path and limit edge radiation. Third, laser microvias, pads, and interlayer transitions between the top layer high-frequency structures and the inner circuits must all be included in the electromagnetic model. Fourth, after any change in material or dielectric thickness, the trace width, length, and matching structures all need to be recalculated. Around 77 GHz, even very small dimensional deviations can cause significant changes in impedance and phase. RO4830 can use many processing steps similar to standard epoxy resin processors and is compatible with the RO4400 series patch structures. It supports mechanical drilling as well as ultraviolet or carbon dioxide laser processing. For multi-layer boards, desmearing is still required before copper plating according to the structure, but the material does not require any additional special activation treatment before metallization. RO4830 has a relatively low glass fiber content, which helps improve electrical uniformity and laser processing performance. However, if the copper distribution on both sides of the cover layer is unbalanced, it can also increase the risk of inner layer processing issues and warping. Therefore, special attention must be paid to copper balance and interlayer symmetry in hybrid multi-layer designs. In terms of thermal performance, RO4830 has a decomposition temperature of 408 to 412 degrees Celsius, a thermal conductivity of 0.45 to 0.47 watts per meter Kelvin, and meets the UL 94 V0 flammability rating, as well as lead-free processing requirements. To summarize, RO4830 is a thermoset high-frequency material designed for 76 to 81 GHz automotive radar. Its typical advantages include a controlled design decay at 77 GHz, low roughness copper foil, low transmission loss, excellent laser drilling performance, and compatibility with hybrid multi-layer structures using FR4. It is typically suitable for use as a high-frequency outer layer of multi-layer radar PCBs rather than simply replacing all the FR4 in the entire PCB. When designing, it is important to focus on confirming the thickness of the high-frequency cover layer, the type of copper foil, the dimensions of the transmission lines, the balance of interlayer transition copper, and the actual manufacturing tolerances. If you are designing a RO4830mm wave radar PCB, PCBSYNC can assist with hybrid stack-up evaluation, impedance and millimeter wave trace inspection, laser micro via DFM, prototyping, and mass production. Scan the QR code in the image and upload your Gerber files to start a quotation inquiry. If you found this content helpful, please give it a like,